In this video, we're going to be using Faraday's law to solve for the current required in order to plate out a specific amount of metal. So the problem that we're going to be looking at is what current is required to plate 50 grams of indium from a solution of indium-3 in 1.5 hours. So to start this problem, same as every problem, we're going to write our half reaction. So in this case, indium-3 is going to gain 3 electrons to form indium solid. So we have a 1 to 3 mole ratio of our electrons. Once we have our half reaction, we can get going on our problem. So we're going to start with that 50 grams of indium. We always want to work with moles when we're doing any sort of stoichiometry problem. So we're going to then take 50 grams of indium, and we're going to divide that by the molar mass of indium. So that's going to be 114.82 grams of indium. Extend that a little bit for 1 mole of indium. So that calculation there gives us moles of indium that we're actually going to be plating out. Our grams here are going to cancel. So our next step is going to be turning moles of indium into moles of electrons. So from our half reaction, we know that for every 1 mole of indium we plate, we use 3 moles of electrons. So we now have moles of electrons, and our moles of indium will cancel. Next up, we want to turn that moles of electrons into coulombs, or to charge. So we know that 1 mole of electrons has a charge of 96,500, or 9.65 times 10 to the 4 coulombs. So at this point, we've now solved for coulombs, and our moles of electrons will cancel. And we know that current is coulombs per second. So our last step is to divide by time. 1.5 hours is 5,400 seconds, because 1 hour is 3,600 seconds. So when we do all of this math together, 50 divided by 114.82 times 3 times 96,500 divided by 5,400, we would need to run 23.3 amps for 1.5 hours to plate out 50 grams of indium.